to the physics class. Today we will discuss about relative velocity. Now my dear students, as in lower classes and in earlier discussion also, we have discussed that the rest and motion, these two terms are relative. Means an object which is in rest with respect to another object need not to be in rest with some other object in other reference frame. For example, if you and me traveling in the same bus, sitting by side, and a person standing in the road or standing in the bus stand, now when the bus moves, with respect to that person, you are in motion. Now, with respect to me, you are in rest. So that's why at the same time, you are the same person, single person, you are in rest with some other person who is standing outside, that means other reference frame. And at the same time, you are in rest with respect to me, who is sitting beside you at the same reference frame. So this rest and motion, these two terms are completely relative terms. So similarly, velocities of the objects, like suppose if I am standing here and if a person or a body moves along a straight line covering equal distances in equal interval of time, suppose for example 5 meter in 1 second. So in each 1 second the object is covering 5 meter each. So with respect to me, the velocity of the object is 5 meter per second. So till I am in rest, the velocity of the object is 5 meter per second. Now consider that if I start moving with covering 2 meter distance in each second along the same direction. Now the question is, will be the velocity of the object with respect to me till 5 meter per second? Obviously not. Why? Because as I move in the direction of the object with a speed of 2 meter per second, so right now the relative velocity between us will be 5 minus 2, that is 3 meter per second. And the opposite happens when we cross each other, not in the same direction but in the opposite direction. So the object moves with the velocity 5 meter per second, and if I move with the velocity 3 meter per second or 2 meter per second, whatever, so then the total velocity, the relative velocity gets added. In our day-to-day life, you can get these examples when if a bus is overtaking another bus, you will find the relative velocity between the buses, it appears slow. But when they cross each other, then the velocity of the buses appear to be larger than the normal velocity. That's why the velocity gets added. So you can see here the example I have shown here. Two cars, they are moving in the same direction. As a result of that, what happens? The relative velocity between them is actually the subtraction, the result of the subtraction of the two velocities, whereas for opposite direction, when the cars move in opposite direction, their velocity gets added. So to discuss this, I have actually separated this discussion in three parts. I have divided this as one-dimensional, then that is a plane, that is two-dimensional motion, and the motion at an inclined angle. So I will discuss one by one that in one dimension how to calculate the relative velocity. For that, I have taken suppose two objects, as I have said, A and B. Now VA is the velocity of the first object A, and VB is the velocity of the second object. Where VA is greater than VB, you can see from the length of the vector. Now to find the relative velocity, what we have to do? We have to first bring this B at rest. Not really, in reality, virtually. Virtually we have to bring it in rest. Now in order to bring this object in rest, how to bring it in rest? If we apply an equal and opposite velocity to this object, the object will come to rest. Like VB, if I apply another minus VB over here, minus VB means magnitude same, direction different. So this B will come to rest. Now to counterbalance this, at the same time we have to also apply this minus VB with VA. So here VA and here I am applying minus VB here. Okay. So what will be the total velocity now? So this will become 0 because you can see VB minus VB, and this becomes VA minus VB. Okay, so that's why we are getting, if it is in the same direction, as you can see they are moving in the same direction, the relative velocity is actually VA minus VB, where VA is greater than VB. And also, if it moves in the opposite direction, then how to do that? So from this equation, if A and B are in opposite direction, like this case, A and B are in opposite direction, so from this expression, we can find out how VA minus, now see, as I have said that it is in opposite direction, so minus of minus VB, because direction of A and B are different, opposite. So it becomes VA plus VB. As you can see here, I have shown here that this becomes the addition. So remember this, that in one dimension, if the objects are moving in the same direction, then their velocity, relative velocity, how to get that? The subtraction of the velocities. And if they are moving in the opposite direction, then the relative velocity, how to get that? The velocity gets added, VA plus VB. So remember this one, two conditions, moving in the same direction and moving in the opposite direction. Next, we will discuss about the relative velocity in plane, that is two-dimensional motion. Now to understand this, first suppose this is the coordinate of axis, this is the origin O. Okay. Now with respect to the origin, let the position vector of any vector, any object A, let that be, this is the point A, so this is the vector, position vector. Suppose this is SAO. I am writing like this, the position vector. The OA vector is actually OA equals to, I am writing here, OA vector is the position vector of A at time t, any time t, and that is written as SAO, position vector. Similarly, the position vector of B, suppose that is B is BO with respect to origin at time t. So this vector, position vector OB, becomes SBO. If I now join the line A and B, if I join the line AB, so suppose this is SBA. So from the triangular law of vector addition, so we can write that AB plus OA, so OA plus AB equals to OB. Because from triangular law of addition, see, same direction two vectors are there, one is OA in same direction, OB, and sorry AB in the same direction, but see OB is in the opposite direction, so OB is equals to OA plus AB. That means from this equation we can write SAO plus this one SBA is equals to SBO. Remember this equation. Now as these points A and B are in motion, so with respect to time they change their position. Their position vectors change with time. Now suppose, consider that at time delta t, small time delta t, which is almost tends to 0, so this A moves by a distance, suppose delta SAO. This is the movement in delta t time, change. And similarly, B point moves by a distance delta SBO. So now, what will be the value of SBA? So SBA will also change by an amount delta SBA in time delta t. So now this equation, this particular equation can be written as, so if I write SAO plus delta SAO plus SBA plus delta SBA, that is the change, will be equal to SBO plus delta S BO. So this is in time delta T, it has increased by this amount. So all of this increased by this amount. Now see, from this SAO plus SBA equals to SBO. So these two are equal to this. So they get cancel out. So what remains from this equation is delta SAO plus delta SBA is equals to delta SBO. So if I take it in this side, or it can be written as delta SAO minus delta SBO is equals to delta S. You do it like this for easier. I am taking this in right hand side. So delta SBO minus delta SAO equals to delta SBA. I can write like this equation. Now if I divide this equation by delta T, what I will get? If I divide this equation by delta T, if I divide this equation by delta T, delta SBO by delta T minus delta SAO by delta T is equals to delta SBA by delta T. Now as I have said, you have seen delta T tends to 0, so this becomes the velocity. So from this delta SBO by T, S by T means velocity, so I can write it as VVO, so it can be written as VVO minus this is VAO will be equal to VBA. So if I emit the origin term O from here, so I can write like this, VBA will equal to VB minus VA. That is the velocity of B with respect to A. The velocity of B with respect to A, VBA equals to VB minus VA. So in two dimension also we can see that the relative velocity you get like this. And the third topic, so we have discussed this also. Now is motion at an inclined angle. We will discuss this. I hope this is clear to you. Next, so the last topic of relative velocity, the last part of this topic is how to find the relative velocity between two objects who are inclined at an angle. So for example, suppose there are two objects moving. One is along this A and another is along this B. So suppose this is A moving with velocity VA and this is object B moving with velocity V, and let B angle between A and B is theta. So how to find the relative velocity between these? Suppose V is the velocity here and V is the velocity here. Now here we will use the law of parallelogram of addition of vectors. So first what we will do, this VB we will oppose it, we will take minus VB. So if we take minus VB, so this becomes minus VB, right? This is minus VB. With that A you have to add, so this is A, so this is VA. Okay, fine, got it. Angle between them, this is theta. So what is this angle? This will be 180 minus theta, right? 180 degree minus theta. So now if I complete the parallelogram, so this gives the resultant of these two vectors, V and VB. So suppose this is VAB. Okay, this is VAB. So from law of parallelogram of vectors, VAB, we know that VAB equals to root over of mod of VA square plus mod of minus VB square, because this is minus VB, plus 2 into VA mod of VA into mod of minus VB cos, now angle between here 180 minus theta, so cos 180 minus theta. This is from law of parallelogram of addition. So what we are getting as VAB as VA square plus VB square, so cos 180 theta minus cos theta is minus cos theta, so minus 2 VA VB cos theta. Cos 180 minus theta means minus cos theta. So from this we are getting this equation. Fine. So this is the velocity, magnitude of the relative velocity. Now in order to find out the direction, so suppose if VAB makes an angle, if it is alpha, if this relative velocity VAB makes an angle alpha with VA, then tan alpha, how to get? See, B sin theta by A plus B cos theta. So minus mod of VB sin 180 minus theta by VA plus mod of minus VB cos 180 minus theta. So if we calculate this, it comes as VB sin theta by VA minus VB cos theta. So this is the direction of the vector which you are getting. Okay, hope this is clear to you. You will read like this: the relative velocity, the concept of relative velocity, and how to calculate the relative velocity in one dimension. There are two cases: objects moving in the same direction, objects moving in the opposite direction. Then the relative velocity in a plane, that is in two-dimensional motion, and also the relative velocity, how to calculate the relative velocity when two objects are moving with an angle or at an angle to each other. Thank you so much. We'll see you in the next class.